In this video, I'm going to be giving a few pointers, including the steps to solving linear equations, clearing fractions, as well as checking your solution both by hand and in the calculator. So, a linear equation is an equation where the highest exponent on the variable is 1. So for example, we're going to have 3x plus 5 equals 2x minus 11. That's a linear equation. There's no x squareds or x cubes. There's just x to the first power as the highest exponent. On page 662 of the text, there is a slightly different version of these steps. Either of these methods will work, but I find that the steps, I've switched a little bit of the order, and I find that it does decrease some of the small mistakes that can happen, but it is a style thing, so whichever way you choose is up to you, as long as you're showing me your work. So the first step is to simplify both sides completely by distributing or combining like terms. In the future, there may be some more complicated things to this, but for now, this is all that we have. The second step is to clear the fraction. If necessary, there may not be a fraction to clear. However, if there is, you're going to multiply every single term in the entire equation by the least common denominator, or the product of the denominators will work as well. All of the denominators should cancel, so they're making 1 basically. The next step is to bring all of the x terms to one side and then all of the constants to the other. Then we're going to solve for x by multiplying or dividing. And then lastly, you're going to check your solution by plugging the value into the original equation, the very first one that's given to you, or by using the store feature in the calculator. So let's look at a few examples here. Solve the following equation for the variable, check that your solution works. So over here I made a secondary link of how to check this solution in the calculator. Regardless of what type of calculator you have, the function should be the same. But if you find that your calculator is different, please contact me or just Google the type of calculator you have in the store feature. So the equation that we're going to check is -3 times the quantity 2t minus 5 plus 2t is equal to 5t minus 4. So the first step is to simplify everything completely. So that's going to be utilizing the distributive property for the first quantity here. So this is going to get us -6t minus 3 times minus 5 is going to be a plus 15. This 2t comes down here, it's just chilling, nothing has happened to it. And then the right side, there was no simplification, so I would just leave that alone completely. We have more simplification to happen on the left side of the equation. So -6t plus 2t is going to bring us to a -4t plus 15. And again, that right side stays the same because there's nothing to happen to it. So you have two options. You can bring the whatever is negative over to the one that is more positive, or you can bring everything of the variable over to the left side. That's a style thing. That's going to be up to you. I chose to bring everything to the left side. In another example, I'll show what happens if you bring it to the other side. So I subtracted 5t from both sides. That's the opposite of 5t. So if I subtract 5t, I'd have 5t, I'd take 5 away, so then I would be left with 0 t's over on this right side. On the left side, we would end up with -9t, and then everything else that wasn't touched just comes down. The next step now, this is our t side, and we've got some numbers without variables here, so we're going to get rid of that 15 by subtracting. And then we end up with -9t is equal to -19. In order to get the t all by itself, we're going to need to divide both sides by -9 and end up with this really glorious fraction here. You need to have a little bit of confidence with this because the answers can be fractional. Using the store feature over here, you'll be able to see that this answer does check out perfectly. It's a really, really gross decimal or fraction, depending on the mode of your calculator. But this is a really straightforward way, once you get comfortable with it, to assure that your calculation is correct. let's look at a second example where we have a fraction to clear. I think clearing the fraction is amazing. I don't like fractions either. I don't think that many students do. However, fractions exist in the real world. Most things aren't really nice whole numbers. So the first problem that we have here is x divided by 2 minus 1 is equal to x divided by 5 plus 2. So I have a lot of fractioning things going on here. One option that you do have is to get everything to have a denominator of 10. So that's the least common denominator. You could make this have a denominator of 10. You could make this 10 over 10. You could make this be 20 over 10. I don't recommend doing that. That's honestly not what I would do personally. I want to just get rid of the fraction. So what we do is we take this least common denominator. It doesn't actually need to be the least common denominator. It just needs to be something that is a product of these two. So 40 would work. We would end up with the same answer at the end. But the least common denominator here is going to be 10. So what we do is we multiply every single term by 10. I do this individually. I do not do this out in front as one big distributive property. I like to physically cancel. So what happens is this is 10x over 2. 10 divided by 2 is 5. So that's going to be 5x here. This is going to be a regular minus 10. It's actually really easy to leave out the parts that don't have fractions. So this is going to be 10x over 5, which will be 2x, and then 10 times 2 is 20. So in our next line, we're going to get 5x minus 10 is equal to 2x minus 20. So again, I'm going to bring the variables over to the left side by subtracting 2 from each side. That's going to get us 3x minus 10 is equal to 20. So I've declared my left side as my variable side, which means I need to get rid of that minus 10 out of my variable side on the left. I'm going to do that by adding 10 to both sides, and then I'm going to be left with 3x equals 10. Divide both sides by 3. X is going to be 10. So the check here is going to be really nice because we have nice whole numbers and everything. The 2 and the 5 are both divisible evenly into 10. So our check is basically going to start from the absolute first line that you were given here. So 10 divided by 2 minus 1 is equal to 10 divided by 5 plus 2. That's 5 minus 1 is equal to 2 plus 2. And this is a true statement, which means our solution of 10 does work out. So my last piece of advice here is about cross multiplying. I find that it's really easy to get like cross multiply happy, and people just kind of want to cross multiply things all the time. It's kind of fun. So again, it can be tempting to cross multiply illegally. However, there's only one little tiny specific instance when cross multiplying is allowed, and that is when you have two fractions equal to each other. So you can only cross multiply when you have two fractions equal to each other. Only. So my accidental redundancy, I guess, was maybe for emphasis here. So the terms can be more complicated, but here we have two fractions only equal to each other. Whenever you can cross multiply, you may also use the steps declaring a fraction. This is a style choice. So you could also multiply both sides by 20, and that could also get rid of that denominator as well. You have multiple options. I want you to choose the one that makes the most sense to you, and then eventually maybe worry about some other ways of doing things. So I have one example for cross multiplying. This may not look like the original cookie cutter form of two fractions equal to each other. However, we can make that right side into a fraction by putting it over 1. So 3x minus 2 is the same thing as 3x minus 2 divided by 1. So we haven't done anything by dividing it by 1. So our first step, again, we're still following the same 6 steps, is to simplify completely. And right now I have some distributing to worry about. So I'm going to distribute that numerator and get 2x plus 2. Everything else is going to just drop down and stay exactly the same. And now I'm allowed to cross multiply. So I have a fraction, numerator denominator only, is equal to numerator denominator only. So once this happens, you crisscross. So this is going to be 2x plus 2 times 1 is equal to 4 times 3x minus 2. This is actually a similar process as clearing the fraction, but for some reason cross multiplying is a really visual thing for people. So I really think this is a method that might become more popular than clearing a fraction when there is a choice. Left side, nothing to be done. 2x plus 2 times 1 is just 2x plus 2. And then the right side, when we distribute that 4 through, we're going to get 12x minus 8. So now what I've done is, in this case, sometimes you may, if you want to avoid negative numbers, you may want to bring the x, or your variable, it may not be x, it could be t like we saw in the first one, to the larger x. So what I did is I actually brought both x's over to this side. And again, this is a style thing. This isn't something that is necessary. It really is up to you. You have a lot of liberties that you can take depending on what you feel more comfortable with. So once we do that, we actually only have numbers on the left, and my right side is going to be my variable side. So then I'm going to add the 8 to both sides to bring that over to the left. We get 10x equals 10. And we end up getting x equals 1. So there is a step in between these two where I switched, actually, because I kind of ran out of space here. It was 1 is equal to x, but it's x is equal to 1 is saying the same exact thing. Checking this solution is nicer than the first one, in my opinion, because when you plug in that 1 here, you just have some kind of more nicer arithmetic that's happening up here. So 1 plus 1 is 2, times 2 is 4, 4 divided by 4 is 1. On the right side, we have 3 times 1 is 3, minus 2 is 1, and 1 is equal to 1. So the store feature could also be used here as well, but I like to kind of bring the equivalent to what you're doing in the calculator and what you are doing in by hand. If you have any questions, please feel free to email me, and don't forget there are a lot of resources on MyMathLab for your use.